How many of you have ever been stressed? By a show of hands. Looks about right. Most of us have experienced stress at some point in our life, whether it be before writing a big exam or presenting your research at a 3-minute thesis competition. Or if you've ever been out camping and you hear a noise outside your tent, that feeling when your heart starts racing, that's your stress response, and it's your body's way of telling you to be vigilant. From an evolutionary standpoint, it's an adaptive trait, and it actually helps you to survive the threat at hand. But we also know that it can have negative consequences, and in humans, long-term stress is associated with things like heart disease, decreased immune function, and infertility. So we know what stresses us out as humans, but for marine mammals, stressors come in the form of loss of habitat, disease, shipping, not being able to find food, or becoming food for something else. And many of these circumstances are becoming more common in the Arctic as climate change warms the region quicker than anywhere else on the planet. Researchers are now wondering how these changes will impact Arctic marine mammals. And one way to assess how an animal will respond to changes in its environment is by studying its stress response. But it's not easy. Blood sampling is considered the gold standard for measuring stress in wildlife, but I want you to imagine for a second that you're an animal and I'm a scientist wanting to study you. I go out into your environment, I chase you, capture you, and then take a blood sample. How stressed do you think you'd be? But more importantly, how reliable do you think my data would be? Probably not very, because instead of measuring stress caused by the environment, I'm measuring stress caused by my sampling technique. And it's for this reason that researchers are moving away from invasive sampling techniques and are moving towards less invasive options. The goal of my master's research is to measure stress in the Western Hudson Bay beluga population and to identify potential stressors. But I wasn't able to use common sampling techniques like blubber or skin biopsies because the community that I was working in requested that I use less invasive options. And that's when I remembered reading about whale snot. It's been used to study everything from genetics to reproduction to disease. And the great thing about snot is that it's non-invasive, so any stress that I measure in my samples is a true reflection of the environment. So now you're probably wondering, well, how the heck do you blow a beluga's nose? And the answer is with a pole in a petri dish. I place this collection device over the blowhole of belugas as they surface for air and collect all the tiny drops that they release. I then analyze that sample for cortisol, which is a stress hormone. As the Arctic continues to warm, it's becoming increasingly important to understand the impacts on Arctic marine mammals. By using this non-invasive technique, I'll be able to identify potential stressors which can help us manage beluga populations across Canada. Thank you.